Today I want to tell you about my idea of what is nature's best hope. But before I do that, I want to revisit what happened on the East Coast last fall. From Massachusetts all the way down to Georgia, as far west as the Mississippi, all the red oaks got together and decided they would make their acorns at the same time. We call that an oak mast, and this is what it looked like in a lot of places. Well, if you're easily entertained like I am, maybe you took one of those acorns and just watched it. And maybe you were lucky enough to see this. An insect started chewing its way out of the acorn. It chewed and it chewed and made a little hole and then forced its way through that hole, kind of looked like the Pillsbury Doughboy, finally plopped out onto the ground. Very dangerous time for this larva because it is good to eat, full of protein, full of fat, and lots of things are after it. So it's got to get below the ground into a safe place, and it wiggles and squirms, and about 30 seconds down it goes, where it stretches and forms a little chamber. And then inside that chamber, it converts itself into a pupa, and it stays there for 2 years. After 2 years, it comes out as an acorn weevil. Now, a lot of people think weevils have big noses because it looks like they have big noses, but that's actually an extension of the head capsule, and the mouth parts are down here, right at the end of that. Females take those mouth parts and chew a hole down into the center of the acorn, turn around, lay an egg in that hole, and that's how the larva gets down there and develops in safety. Now, you might wonder why they spend 2 years underground. Why don't they come out the next year? And that's because it takes 18 months for red oak's acorns to complete their development. If they came out the very next year, there'd be very few acorns available for them. Well, of course, when the acorn weevil leaves the acorn, it leaves a hole. It's a true vacuum, and you know that nature abhors a vacuum. And there are actually specialized ants in the genus Temnothorax, 3 species that live inside the vacated holes made by acorn weevils inside of acorns. And if they discover a freshly excavated hole, they get very excited. They want to move their old colony, or their colony from their old acorn into this new hole. And they do. They all get together. They work very hard. Everybody's carrying something back and forth till the entire colony is inside the new acorn. Then they post a guard here to make sure nobody else comes in. And that's where they'll live for the next 2 years until that acorn falls apart. Now, about this time, my wife says, "What is your point? What are you trying to tell us?" And my point is very simply, this is the type of specialized interaction that nature is comprised of. Millions of these types of interaction. That's one that occurs in my yard because we've got lots of oak trees. This is another one, acorns dispersed by blue jays, very mutualistic relationship between jays and oaks. You won't have pileated woodpeckers, for example, unless you have lots of carpenter ants. Another specialized interaction, because that is what they rear. Carpenter ants are what they rear their young on. And you're not going to have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have this plant, Facilia. That is the only pollen that particular bee can rear its young on. As a matter of fact, lots of bees, about a third of the 4,000 species of bees in North America, are highly specialized on particular pollens. There are 13 species in our area that can only use the pollen of sunflowers for reproduction. The Baltimore checker spot can only develop on turtlehead, and so on. So nature is a series of these types of specialized relationships. But today, these relationships, nature itself, is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice seriously. In 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, "Leave it as it is." Good advice, except today, of course, that was the beginning of the formation of the Grand Canyon National Park. Today, though, we can't leave most of the country as it was because we have already changed it drastically. There's only about 5% of the lower 48 states that's anything close to its original ecological state. We have logged the country a number of times. We have tilled it, we have drained it, grazed it. We've got 770 million acres of rangeland. And of course, we've paved it and otherwise developed it. We've straightened our rivers and dammed them, and you can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We have drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in natural areas like kudzu is here down south. In short, we have carved up the natural world into tiny remnants of its former self, each one of which is too small and too isolated from each other in order to sustain the species that we need to run the ecosystems that support us. Doesn't seem like a good idea that we've done that. You might wonder why we've done it. The Earth was huge, and we thought it was so big. Our nest was so big that we could foul it forever without any consequences. But of course, we were wrong, and that's why we're seeing headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Followed by this one, North America has lost 3 billion birds, a third of its entire population in 50 years. As a matter of fact, the UN now predicts that we will lose 1 million species to extinction in the next 20 years. I could go on, but this is not a talk about the pox that we have delivered upon our environment, thus upon all of our houses. This is a talk about the cure for that pox. It's a cure that will take small efforts from lots of people, but they will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return to this headline briefly. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, E.O. Wilson, the great Edward O. Wilson from Harvard, told us what it would mean if we were to lose insects. And he did that in this paper, The Little Things That Run the World, way back in 1987. He was talking about the importance of conserving invertebrates, and those invertebrates are largely insects. His message was clear. If insects disappear, life as we know it would change drastically, because life as we know it depends on insects. If they were to disappear, so would most of the flowering plants. They would go extinct. And if most of the flowering plants went extinct, that would drastically change the physical structure of terrestrial Earth, but also the energy flow through terrestrial ecosystems, which would collapse the food webs that support our animals, our amphibians, our reptiles, our birds, and our mammals. The biosphere, the living portion of the Earth, would rot because we would lose insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans would not survive any of those drastic changes. The good news is that none of this has to happen. We can save our insects. We must save our insects, actually. We can save our birds, we can save nature itself, but we're going to have to change the way we landscape in order to do it. Why is that? Well, humans, just to remind you, humans are a product of nature. We are totally dependent on the services produced by natural ecosystems. And we cannot live without them. Here are just a few of the services produced by plants, like oxygen. We all need that. Clean water. Plants clean our water. They slow its journey to the sea where it's too salty to use. They capture carbon, pull it out of the atmosphere, and then not only use it in their tissues, but they pump it into the ground and store it essentially permanently. And that is why our soils are brown or black. It's the carbon that plants have deposited there. Enormously important ecosystem service today. Plants build topsoil and hold it in place. If we didn't have plants, the Earth would be a rocky mass because all the soil would be in the ocean. Plants prevent floods, they dampen severe weather, and of course many other things. What do animals do for plants? Well, they provide pest control services. They pollinate about 90% of our flowering plants. They disperse the seeds of those plants and other things. Point is that designing landscapes that destroy these types of ecosystem services is no longer an option. It never was a good option. But today we've got 7.9 billion people on the planet. We need more ecosystem services than ever before, not fewer. So landscapes like this, simply not an option. Well, there were visionaries through the ages who recognized that we needed to improve our relationship with planet Earth. And one of the most eloquent was Aldo Leopold. He's credited as being the father of modern conservation because of the wonderful ideas that he had. He wrote lots of things, and one of the things he said was, the oldest task in human history is to live in a piece of land without spoiling it. Now, there are some indigenous groups that have managed to do that. But by and large, we humans are terrible at that, especially with our expanding populations that are now over the carrying capacity of planet Earth. We go from place to place, spoil it, take more than the Earth can give back, and none of that is sustainable. Well, Aldo recognized that, and he said, we humans need to develop what he called a land ethic. He recognized that we were going to use the land, we were going to farm it, lumber it, graze, mine, hunt on it, but we needed to learn how to do that without destroying local ecosystems. And he wrote about the land ethic in the Sand County Almanac, a very famous book. What has intrigued me, though, is that Aldo never talked about developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect that the notion that humans and nature cannot coexist in the same place at the same time was so deeply embedded in Aldo's day, his culture, and it's still embedded in our own, that he didn't recognize it as an option. Well, today I'm going to argue that not only is living with nature, not only is it an option, but I'm going to argue that today it's the only viable option that is left to us. In the past, conservationists worked exclusively where there weren't any people. We need to turn that on its head now. We now need to start saving nature, restoring nature where there are lots of people, because that's most of the Earth. So in other words, we need to find a way for nature to thrive in human-dominated landscapes. Where are we going to start? Well, back to this picture. We cannot ignore private property because most of the country is privately owned. 85.6% of the U.S. east of the Mississippi is privately owned. If we didn't do conservation on private property, we would only be doing it on 15% of the property, assumed we did it on all public property. And that is not nearly enough. That's what creates those isolated habitat fragments. Plus, there's a lot of places that we don't typically think of as conservation options. How about power and pipeline rights of ways? 21 million acres in power and pipeline rights of ways. Lots of opportunity there. Railroad rights of ways, another 3 million acres. Golf courses, 2 million acres. Airports, 3 million. The Denver airport is twice the size of Manhattan. These are huge places. Then we have all the places where we live, from rural areas to suburbia to urban centers, hundreds of millions of acres in those areas. Roadsides, we got 4 million miles of paved roads. All of those roads have two sides to them. That's another 17 million acres. If you add up just these opportunities, and you can think of many others, that's 599 million acres. How big is 599 million acres? Well, it's bigger than Vermont, plus New Jersey, plus Maine, Virginia, New York, plus Georgia, Florida, Oklahoma, Montana, California, and even throw Texas in there. So not having a place to do conservation is not the issue. We can do conservation almost anywhere. What is it we're going to do? We're going to put nature back together again. Will it look exactly like it did before we spoiled it? Probably not. Almost certainly not. Does that mean we can't reestablish functional relationships? No, it doesn't. We can and we must. But when we're reconstructing functional natural systems, we have to start with the species that other species depend on. Not all species contribute equally to ecosystem function. And one of the most important things we need to do is establish functional food webs. In other words, plants, of course, capture the energy from the sun, turn it into food. That energy has to get to animals, or it's locked up in the plants, and then you don't have any other living things. Well, most animals don't eat plants directly. They eat something that ate plants, and most of those plants most of those somethings are insects, and most of the insects that eat plants that pass that energy on are caterpillars. It turns out that caterpillars are essential components of food webs because they're transferring more energy from plants to other animals than any other type of plant eater. Imagine what would happen if we removed caterpillars from our ecosystems. Let's use the Carolina chickadee as an example. They, of course, we see them in our feeders today, right now, eating seed, and we think that's all they need. But when they're reproducing, their young cannot eat seed. As a matter of fact, most baby birds cannot digest seeds. So what do? They switch to insects, and most of the insects that they rear their young on are caterpillars. And it turns out chickadees are not exceptions. 96% of our terrestrial birds are rearing their young on insects, and again, most of those insects are caterpillars. And here's a little bit of data to possibly convince you of that. This comes from Ashley Kennedy, one of my former students who did a citizen science project. She asked people to take pictures, good photographs of birds while they were bringing food to the nest from all over the country. She got about 7,000 pictures to work with. And then she constructed nestling diets based on what the birds were carrying to the nest. The green bars, you're looking at 20 families of birds in North America. The green bars are the percentage of the diet, the nestling diet, that was caterpillars. And in 16 out of the 20 bird families that you're looking at here, caterpillars dominated the diet. So imagine what would happen if we took caterpillars out of our landscapes. All of these birds would not be able to reproduce. So why caterpillars? What's special about caterpillars? Lots of things are special about caterpillars. For example, they're soft. Imagine this guy as a sausage with a very thin wrapper. The thin wrapper is exoskeleton, it's cuticle, it's undigestible, and birds don't want a lot of that. And it surrounds a lot of good food, a lot of protein, a lot of fat. And because they're soft, the birds can stuff them down the throat of their offspring without fear of injuring them. If you've ever watched a parent bird rear its young, it's pretty rough. Take their beak, it's like a plunger, they just stuff it down there. They're also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. So some of our smaller birds do chase aphids around. They're doing that right now during migration. But do you want to chase 200 aphids or get one caterpillar? They're nutritious, as I said, high in fat, high in protein. They have a low percentage of chitin compared to many other insects, particularly beetles, which are not like little sausages. They're like little tanks, and they've got lots of sharp edges. And it turns out caterpillars are the best source of carotenoids for birds during the breeding season. Now, I mentioned carotenoids not because I love organic chemistry, but because I'm a vertebrate, and you're a vertebrate. And birds are vertebrates, and vertebrates cannot make their own carotenoids. Yet they're essential components of vertebrate diets. Only plants make carotenoids, so we all have to get our carotenoids from plants. And that's why my wife Cindy says I need to eat my carrots to get my beta carotene, and I need to eat my tomatoes to get my lycopene. I need to eat whatever that is to get my lutein, and she makes sure I get lots of carotenoids through those foods because they stimulate my immune system. And I cannot think of a better time to have a strong immune system. They're antioxidants. They run around our body, protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but turns out she was right. They improve sperm vitality. They improve sexual attractiveness. And we're talking about largely male birds, like this prothonotary warbler. He is bright yellow because he's had access to lots of luteins. And he has taken those luteins and built pigments out of them, put them in his feathers. And the brighter yellow he is, the more ladies he will attract. Well, birds are getting their carotenoids from what they eat, particularly when they're reproducing. And as you can see, the prey items that birds bring back to the nest do not contain equal amounts of carotenoids. These first two bars here are, where are they? Right there, are types of caterpillars. And they have far more carotenoids than other types of insects. The third bar is orthopterans, things like crickets and grasshoppers and katydids. Here are the adult caterpillars down here, the moths and the butterflies themselves, far fewer carotenoids because they're not eating green leaves. That's where the carotenoids come from. And here's the earthworm way down here. The early bird gets the worm, but doesn't get any carotenoids when he does. Are birds choosing prey items based on their carotenoid content? Well, Ashley Kennedy did another study with bluebirds. She put GoPro cameras on the roofs of bluebird boxes, and those cameras took a picture once every second. The idea was to capture the bluebird as it was flying into the box, so that she could identify what the bird was bringing to the nestlings. And she had lots of bluebird boxes and lots of GoPro cameras, and she did it for 3 years. So she ended up with over 1 million pictures that she had to go through. But out of that 1 million pictures, she got 7,628 pictures that were good enough to identify the prey item. And she found this very nice relationship between the frequency with which the prey item was brought back and the amount of carotenoids that that prey item had. Caterpillars brought back more than anything, and they had the highest amount of carotenoids, followed by those orthopteroids, and then everybody else is nestled down here. So all of this suggests that caterpillars are not optional parts of bird diets. It's starting to look like they are essential parts of bird diets. Caterpillars are necessary for birds, but how many caterpillars do birds need? Is one or two enough? Well, that's a good question. But if we actually look at the amount of prey that birds are bringing back to the nest when they're reproducing, it turns out that it's far more than one or two. We can look at chickadees. How many caterpillars does it take to make a nest of chickadees? Thousands, 6,000 to 9,000 caterpillars, depending on the number of chicks in the nest. And that's just to get them to the point where they leave the nest, where they fledge. Parents continue to feed them caterpillars for another 24 days after they leave the nest. So who knows how many thousands, because they're flying around, nobody can count those. And remember, chickadees are breeding. If we want them to breed in our yard, we have to have all of this food in our yard, all of these caterpillars, because they're only foraging about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. So if you don't have that amount of bird food in your yard, you're not going to have these breeding birds. And of course, we have not been designing our yards in a way that do produce that many caterpillars. So in other words, locally we have insect declines, and there's growing evidence that that is causing bird declines. Remember the study that said we've lost 3 billion birds in the last 50 years? That was Rosenberg et al. Well, they posted their data, and we took a look at it to see which birds were actually declining. And it's not all birds. The birds that required insects during some part of their life history lost on average about 10 million individuals per species. But there are birds that don't require insects. The doves and the finches, they can reproduce off seeds. They didn't lose at all. As a matter of fact, they gained a few million individuals per species. So this is not cause and effect, but there's definitely a strong relationship between needing insects and how well the birds are doing. Birds aren't doing well when insects are decreasing, that's for sure. So we have to landscape in a way that creates caterpillars. New way of thinking. We haven't been doing that in the past. How do we do that? Well, we add caterpillars to landscapes by adding the plants that make them. Sounds easy enough, and it is pretty easy, but there is a catch, and that is most plants don't make a lot of caterpillars. If you look at the way the caterpillar species are supported by plant genera, there are just a few genera way down here. This is the number of plant genera that are supporting most of the caterpillar species. This first line here are oaks, way high. This is data for the Southwest, but all of these graphs for each region look the same. Whereas most plant genera are supporting either no caterpillars or very, very few. Hundreds of plant genera. This is based on 1,531 plant genera in these Southwest places. And this is a very typical scenario. Most of our native plants are not supporting very many caterpillars. Why is that? Well, most caterpillars are very, very fussy about what they can eat. We call them host plant specialists. So you have to add the plants that host those specialized caterpillars, like the monarch butterfly here. Monarchs, of course, are only going to eat milkweeds. If you load your landscape with crepe myrtle, you're going to have crepe myrtle, but you're not going to have any monarchs. You've got to have those milkweeds. Why are caterpillars specialized on particular plant lineages? Why are most insect herbivores host plant specialists? Well, plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their tissues with nasty tasting chemicals, secondary metabolic compounds that make those tissues either bitter or downright toxic. And a lot of plants have physical defenses as well. And it's a very effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there. It's not because there are no insects out there that could eat those plants. It's because most of the insects that are out there are unable to eat most of the plants. They're too well protected chemically. But of course, we do know that insects eat plants, so how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. About 90% of the insects that eat plants are what we call host plant specialists. Over the eons, they become associated with particular plant lineages, and they get very good at getting around the defenses of those lineages by adapting to those defenses. They develop specialized enzymes that store and excrete and detoxify the defensive compounds, behavioral adaptations and life history adaptations that minimize their exposure to plant defenses. But again, it takes long periods of exposure to those plant lineages for all those defenses to fall into line. And remember, they can only do this for a few, one or two plant lineages, because every plant lineage that's out there is developed in a different way. And insects cannot adapt to all of them at the same time. That's what creates this specialization. Point is, plant choice matters. If we're trying to reestablish or restore natural interactions in a given place, you have to pick the plants that will enable that. And I'm going to give you 3 examples of how well this actually works. And I'm going to start with my own house here, our own house. I'm actually sitting in that room right up there. This is what it looked like when we moved in. We owned 10 acres in Oxford, Pennsylvania. It was a farm that was broken up. It had been in farming for 300 years. The soil was exhausted. Last bit of farming they did was to mow it for hay. But what they really were mowing for hay were all the invasive species from Asia and calling it hay. And of course, they stopped mowing before we moved in. So when we actually owned the property and started to walk around, this is what it looked like. 10 acres of invasive species. Multiflora rose and oriental bittersweet and Japanese honeysuckle and bush honeysuckle and autumn olive and porcelain berry and calorie pear and privet, and you know what they're all about. This is my wife Cindy. She's getting ready to get rid of all of this stuff, which she did successfully. What was I doing? So by the way, if you think you can't clear 10 acres because it's too much work, Cindy did it, so you can do it too. What I was doing was telling her she was doing a great job, but I also was putting some of the plants back. Not back, reintroducing plants that hadn't been there for hundreds of years. And I was selfish about it. I wanted to bring in plants that I knew or hoped would support caterpillars that I wanted to take pictures of. So this is an example. I wanted the Canadian owlet because I think it's pretty, and that's what the adult looks like. A very good example of crypsis. Well, to have Canadian owlets on our property, we had to have meadow rue. We didn't have any meadow rue. And I don't know where there's any meadow rue around here. The whole area had been exhaustively farmed. The meadow rue is long gone. So I got some seeds of meadow rue and planted it. And I didn't know how long it would take for those moths to actually find my meadow rue. I thought we were looking at years. So I did not go out and check my meadow rue the first couple months. But then I did go out, and it was practically defoliated because the Canadian owlets had found it right away. And now I have a thriving population of meadow rue and Canadian owlets. Same story with the goldenrod stowaway. Actually, it's a misnomer. It has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa. Ditch daisy. Again, we didn't have any Biden's aristosa, but I did know where some was, about 15 miles away in a power line cut. So I got seeds, brought them in. They grow very nicely. Took a year, but the goldenrod stowaway came, and now we have a great population of both. I wanted the hackberry emperor because it's a butterfly that ought to be at our house. Used to be at our house before they got rid of the hackberries. Well, I put hackberries back. That's the only plant they're going to eat. And again, this one took 2 or 3 years for them to find, but we have a great population now. I went out in June, looked at one of the branches of one of my hackberries, and there were 9 hackberry emperor caterpillars on it, so big success. I did not plant goldenrod, but it came in on its own, and along with it came the beautiful caterpillars that eat goldenrod. There's 110 species that develop on goldenrod in my area, like the brown hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. Now here's what I'm waiting for, the goldenrod flower moth. We've been in, this is our 20th year now, and the goldenrod flower moth still has not found our goldenrod. So this is anticipation. It's like waiting for the ketchup to come out of the bottle. One of these days, I'm going to go out. That's what the caterpillars look like. And I'm going to find goldenrod flower moth, and it'll be a great day. Planted Virginia creeper for the same reason. I wanted to attract particular insects like this beautiful Pandora sphinx and its equally beautiful adult. But I got a lot of other things. They weren't my targets, but they came anyway, like the lettered sphinx, the hog sphinx, the abbot sphinx, all eat Virginia creeper as well as many other things. Wanted the zebra swallowtail because I think it's our prettiest swallowtail. Well, it's a specialist on pawpaw. We didn't have any pawpaw, of course, but there was a population about 26 miles away. We got some pawpaws, ate the pawpaws, and threw the seeds around. Well, it took 9 years for that butterfly to actually go those 26 miles and find our pawpaw, but they finally did. But in the meantime, we got the pawpaw sphinx. I didn't know there was a pawpaw sphinx, and lots of pawpaws. I wanted the double-toothed prominent because it looks like a little dinosaur, and I think that's cool. So we planted elm, that's what it eats. I wanted the evening primrose moth because it's beautiful, and I like beauty just like anybody else. So we planted evening primrose, and this is what they do during the day. The moth just hides in the middle of the flowers. It's very cute. And we planted lots of oaks. Now, these are just examples of some of the things we put in our property. But oaks were special because they support so much life. This is the Bedford oak in Bedford, New York. And people argue about whether it's 300 years old or 400 years old. And a lot of people think you have to have, your oak has to be massive like this in order for it to contribute to your local ecosystem. But that is simply not true. I planted most of our oaks as acorns or 1 or 2 foot bare root whips. By the way, that means they were free or very cheap. But they were small, but right away, the things that support, or the insects that oaks support started coming, like the solitary oak leaf miner, or the juvenile's dusty wing, or the orange-shouldered moth, or the orange-headed epiclema. I think it's a yellow-shouldered moth, sorry about that. The red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crowned bugulatrix, the white-blotched heterocampa, the oblique heterocampa, the red-lined panapoda, the laugher, and literally hundreds more species of moths have come to my oaks, and they come right away. This is a pin oak, first year, poked its head above the leaf litter, and here's a crocus geometer standing on the ground eating the leaves of that leaf. So you don't have to wait hundreds of years for your oak to produce. They start supporting your food web almost immediately. This is a picture from the same perspective that I took the first picture. We have a little lawn there, very traditional. But, I put the plants back. I put a lot of the plants back. So still adding plants. And every time I add a plant lineage, new species of moths come to my yard. Now, we haven't started counting the butterflies yet. I'll get to that one of these days. But I'm still busy counting the moths. I wanted to see how many moth species we have on our property. So I have taken pictures of 1,012 species of moths. 1,012 species so far. I am not finished. Of bird food. That is 39% of all the moths found in Pennsylvania, which is 2.4 million acres, found on 1/240,000th of the land mass. And because we have so much bird food, we have recorded, this is outdated, 57 species of birds have bred on our 10 acres, which is 30% of all the birds that breed in Pennsylvania. So point is, it works. I saw this headline last week. World Wildlife Fund says the Earth has lost 2/3 of the wildlife since 1970. We humans have destroyed 2/3 of wildlife on planet Earth since 1970. Well, my reaction to that is not at our house. Not at our house. I'm willing to bet that we have more than increased the wildlife at our house by 2/3. Because when you put the plants back, it comes. But I know what you're thinking. We own 10 acres and a lot of people don't. So will this work in a typical suburban neighborhood? That's a good question. Let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. They own 0.6 acres, so just over half an acre, and it's a typical suburban lot. And they are in a typical suburban neighborhood with lots of big lawns and not too many plants. But this is their yard, and what they did was get rid of their major invasive species, which is bush honeysuckle, put in lots of native plants, and something they call a bubbler, a little water feature. And then they sat back and started to count the birds. They have recorded 149 bird species at their house, including 35 warbler species. Just to put that in perspective, we have 10 acres, and we have recorded only 8 species of warblers at our house. So on just over half an acre, they're attracting all of this life. It works. What about in an urban yard? Well, let's go to Pam Carlson's house in Chicago, and I mean in Chicago. She lives right next to one of the runways of O'Hare Airport, right next to Kennedy Expressway. She has 1/10 of an acre. That is 3 times smaller than the average lot size in North America. And there's no connectivity between her yard and any other natural area. She is an island. Well, she put in 60 species of native plants and water feature, as you see there, and then she sat back and counted her birds. 116 species of birds have used her yard, including this woodcock that she took a picture of last year. So if you haven't seen a woodcock lately, go to Pam's house in the middle of Chicago. But what about in city centers? 82% of us live in cities now. We can't leave all those people out. Well, I was looking at this plant in 2014. This is, of course, Asclepias tuberosa, butterfly weed, which reminds me that we have a terrible marketing issue with native plants. We call them weeds and then wonder why people don't plant them. So we're not going to call this weeds anymore. We're going to call it Monarch's Delight. It's not butterfly weed. So I was looking at Monarch's Delight, and the first thing I saw was this bee, this megachilid bee, leafcutter bee. I know it's a leafcutter bee because it collects pollen on its tummy, right here, not on its legs. Well, leafcutter bees have very specific requirements. They need pollen, they need nectar, but they also need soft leaves because they cut the edges of those soft leaves like red buds, and roll them up into a tube and stuff them full of pollen, and that's where they lay their eggs and reproduce on those pollen tubes that they make. They put those in a crack. Well, there was red bud right next to Monarch's Delight, so the leafcutter bees, and actually there were 2 species there, had everything they needed. And because there was red bud there, that means there was early spring forage for bumblebees. Queen bumblebees doing all the work in the early spring. They don't have any workers yet. So they need lots of flowers early in the spring so they can build that colony up quickly. There was red bud there, and there were bumblebees there. And then I saw a monarch. Actually, I saw 2 monarchs. Why were they there? Well, there was Monarch's Delight. There was also other species of milkweed. They had what they needed. They had nectar, and they had the host plant. Now, this was 2014. Remember, 2013 was the low point of the monarch population. Only 3.6% remained compared to 1976. I had gone all of 2013 without seeing a single monarch. And this was also June. Monarchs don't get up the East Coast as fast as they get up the center of the country. So in June is very early for us to see any monarchs at all. So I was very impressed here in 2014. Do you know where I was? I was on the High Line in the middle of Manhattan. Believe me, the middle of Manhattan. And the High Line, of course, it's a renovated, abandoned railroad line that was elevated 30 feet above the cement below, traffic and everything. Millions of people come to the High Line. It's a tourist destination now to enjoy this strip of nature. It's not a big strip. There's our Monarch's Delight. But it's well planted with lots of native plants, not entirely native plants. Now, I'm not much of a city boy. This is Rick Dark right here, right there. And he wanted me to go to the High Line for a long time. Finally, he got me there. I was not excited about it because I knew I'd see pretty plants, but I wouldn't see anything on them. I was completely wrong. I saw all of those things. And we were only up there in 15, 20 minutes. the point is that if thoughtful native plantings can bring life back to the middle of Manhattan, we can do this anywhere. I'm convinced of that. But there are four things we need to consider that I consider to be keys to success. And the first one is we have to shrink the lawn. We have way too much lawn in this country. Over 40 million acres of lawn, which is bigger than the area of New England. It looks like this. And, that's a nice status symbol, but it's a deadscape. So I'm suggesting that we cut this in half. We're still going to have lawn, and it's still going to be manicured, and we'll still be high-class citizens, but we're going to have less of it. They're going to be well-planted. And if we cut the area of lawn in half, we'll have 20 million acres to work with. And if we do this at home, we can create a new national park that I'm calling Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, plus Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Annapolis Park still less than 20 million acres. There's a number of benefits to bringing nature back to where we actually live. It will allow us to develop or redevelop a personal relationship with the natural world, right in our own time, our own pace, right where we live. We can do it avoiding crowds. You know how crowded our national parks are these days. It's free. It's never closed. I don't care how many pandemics come down the road. You can always go out into your yard. No travel hassles, and you get to experience the natural world alone. These days we're worried about our kids not being exposed to nature as we should be. They're exhibiting what Richard Louv calls a nature deficit disorder. So we put them on a bus with a teacher, 30 kids on a bus. They drive to some natural area someplace and they walk around for an hour. And the teacher tells them not to touch anything. Then they get back in the bus and they go back to where they came from. And that's their experience with nature. But it's really an experience with 30 other kids and a teacher telling them not to express or not to touch anything. What they need to do is be able to go out into a natural situation, even if it's just their yard, and develop a relationship with nature by themselves. No parental supervision. It won't kill them, and it'll be great. And maybe they'll get to hunt lizards. I'm learning this from my own granddaughter Zoe, who lives in Hawaii. And this is a picture explaining how to hunt lizards in Hawaii. You disguise yourself with sticks and leaves, and you crawl very slowly on the ground so you can sneak up on the lizards. You have to be serious about it. You can wear your best dress, it's okay. And the lizards she's hunting are little anoles, and this is a game she has invented and she plays frequently. And she's not going to be hunting lizards on the ground in her best dress the rest of her life, but I do guarantee she will remember doing that, and she is now well connected to the natural world. If you want to do more than hunt lizards at home, get this book, Nature Play at Home, by Nancy Stranisti. She has lots of great ideas of what kids can do in very small spaces. So we're going to shrink the lawn. What are we going to put in the parts we take out of lawn? We're going to put what I call keystone plants. It turns out one of the most important things we've learned in recent years in our lab is that not all native plants are supporting life equally. As a matter of fact, there are some real powerhouses. About 5% of them are making 75% of that caterpillar food that drives food webs. 14% are making 90% of the caterpillar food. But that means there's a lot of native plants not doing a whole lot, even though they're native. So the question is not simply, are natives better than non-natives? On average, they certainly are. The question really is, do we want ecologically productive plants in our landscapes? Or benign plants not doing much of anything? Or even worse, destructive plants, those Asian plants that are really invasive species. They escape our yards and pollute our nearby natural areas. I get an email once or twice a year from people reminding me. They say, don't you know that ginkgo biloba from Asia actually grew in North America 7 million years ago? That makes them native, and that means I can plant them and everything will be great. But remember, this is not our metric anymore. I mean, we can argue about whether something was here 7 billion years ago is still native today, but I don't care if ginkgos grew on the moon 7 million years ago. They support 0 species of caterpillars. they are not a productive plant in terms of supporting local life. Here's a productive plant, our oaks. In 84% of the counties of North America, oaks are supporting more species of caterpillars than any other plant. 557 species in the mid-Atlantic states, and that includes Virginia, right next to Ohio. 900 species nationwide. There's no other plant genus that comes close to the productivity of oaks. Here's an example of what a keystone oak in my yard does, or the oaks. I've got more than one. Remember, I've taken pictures of 1,012 species of moss. So far, out of that 1,012 species, 888 have known host plants. Out of the 888, 262 species use oaks. Now we have 59 genera of native woody plants on our property, and only one of them is Quercus, the genus of oaks. And we have hundreds of genera of herbaceous plants. So oaks represent less than 2% of our woody plant diversity and way less than 1% of our total plant diversity. But they're supporting almost 30% of our moss species. Imagine what would happen to the diversity in my yard if we took oaks out of the system. What would happen to the bird diversity if we took oaks out of the system? How do you find out what keystone oaks or keystone species are for your county? You go to Native Plant Finder on the National Wildlife Federation website. You put in your zip code, and the ranked list of both woody and herbaceous plants will pop up for your county. And I stopped here because it just ran out of room. But particularly throughout the East, these lists look really similar. Oaks are always at the top, followed by native cherries and native willows. Notice I'm saying native. You can go to the nursery, you can buy an English oak, or you can buy a Chinese oak. I don't know why you'd want to do that, because we have 90 species of oaks in North America. Surely one will work well in your yard. You can get the Asian cherries, and you can get weeping willow from the Middle East. But when you do that, even though these are native genera, you're adding non-native species, and you will have a 68% reduction in caterpillars. This is a common garden experiment that we did, so I'm not making these numbers up here. Stick with the natives. The most powerful herbaceous plants include goldenrod and asters, and particularly the perennial sunflowers. And these are also the top 3 genera in most of our counties for supporting specialist bees. So you get you kill 2 birds with 1 stone there. All right, we're going to shrink the lawn. We're going to put in keystone plants, and then we're going to attract lots of moths to our property, and then we're going to kill them with our lights. Of course, we don't want to do that. It's turning out that light pollution is one of the major causes of global insect decline. That's what the research is suggesting. Most of it's from Europe. Lights kill particularly moths in lots of different ways. Through exhaustion, they fly around and around and around until they run out of energy. They collide with the light bulb. They get incinerated. They die of dehydration. The bat comes and picks them off. It blinds a lot of these insects. Who knew? And it messes up their daily activities. So again, light pollution around the globe is clobbering our insect population. That this is good news because it's so easily fixed. All we have to do is turn the lights out. And I know what you're going to say. I can't turn my lights out because the bad man will come. Okay, put a motion sensor on your security light so it only turns on when the bad man does come. And the first thing you're going to recognize is that the bad man doesn't come very often. If you don't want to do that, take the white light out of your security system and put in a yellow bulb, because yellow wavelengths are far less attractive to insects, night insects. And yellow LED lights are the least attractive. So by switching to yellow LED lights overnight, we could save billions of insects and a whole lot of energy. Fourth thing we need to do is to landscape in a way that allows the caterpillars we brought into our plants to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, and in Chester County, Pennsylvania, there's 511 species of caterpillars that develop on oaks. A few of them, like the polyphemus moth, complete their development on the oak leaves. And then they spin a cocoon and hang from the branches, and then they emerge as an adult I wish everything did that, but most species don't. 94% of the 511 species, 480 species drop from the tree and wiggle down into the soil where they form a cocoon and spend the winter, or they spin a cocoon in the leaf litter that is under the tree. You know where I'm going here. We don't have any leaf litter under our trees, and we compact our soil and mow it, so this becomes a death sentence for any caterpillar that parachutes out of here. This is an ecological trap. The moths come in, lay their eggs, the caterpillars develop, drop down, and die. And the next generation is smaller, and the next one after that is smaller, and then you've got global insect decline. It's just another reason that our insects are declining. And of course, the cement landscape is even less viable for caterpillars. I am not trying to discourage the use of trees in cities. I am trying to discourage the profligate use of cement as a landscape tool. That's just laziness. And of course, it ruins our watersheds. This is what most people do. We have trees growing out of big lawns, and nobody's measured the success of caterpillars in a situation like this, but I can guarantee they're higher in a situation like this. You have a tree, then you have a layered landscape of natives. So you could have a dogwood over here and ferns and ground cover. The moths drop down into this safe site. Nobody's going to squish them. Nobody's going to mow them. The ground is not compact. You can do your spring ephemeral gardening around all of your trees. Again, safe sites. Put in your ground covers like wild ginger or May-apples or foam flower. This is how you shrink the lawn. You build these types of beds around each of your trees, and all of a sudden you have less lawn. More good news. There's room for compromise in our plant choice. And this comes from research that another grad student, Desiree Naranjo, did recently. She compared chickadee population dynamics in landscapes dominated by native plants and landscapes dominated by introduced ornamentals in typical suburban yards inside the Beltway in Washington, D.C. So these are the types of places where we live. The landscapes dominated by introduced plants produce 75% fewer caterpillars. So right away, there's 75% less bird food available for the chickadees. They were 60% less likely to breed in those landscapes at all. There's a nest box in each landscape. The birds came, they look around, and decided there's not enough food here, we're not even going to try to reproduce. If they did try to reproduce, they laid 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do it. So you might say, well, those aren't huge differences, but if you put all that together in a population growth model, this is what it looks like. As a function of the percentage of non-native plant biomass in your landscape, from no non-native plants to 100%. This dotted line here represents replacement rates. This is the rate at which the population has to make babies to replace the adults that die every year. If you make the same number as the adults that die, same number of babies, you've got a sustainable population. It's not growing, but it's not shrinking. If you make more babies than adults die, you've got a growing, increasing population. If you make fewer, you've got a decreasing population. And right here is where those lines intersect. So as soon as you exceed about 30% non-native plant biomass in your landscape, you're down into this no man's land here. You've got a decreasing, unsustainable population with this much non-native plant vegetation. But this also represents compromise. You can have up to 30% non-native plants in your yard, as long as they're not invasive. You can't have any of those. But you can have your crepemer, you can have your ginkgo. They're not going to move around, as long as it's not 30% of your total plant biomass. Then you can still have viable bird populations. Can native plants be used in formal designs? Of course they can. Somebody sent me this picture in the spring. I've lost track of who it was. It's the land manager of this very formal design. And what he's doing is sneaking in native plants without telling anybody. So here's Joe Pye. I'm not going to call it Joe Pye weed. And his goal is to exchange all of these plants with native plants to show, yes, you can have native plants in a formal design. Formality is not a function of the plants and the design. It's a function of the design itself. Our native plants are used in formal designs in Europe all the time, and I guess that's okay because they're non-native over there. Can we get a pollinator garden into a typical suburban yard like this without offending anybody? Of course we can. We put a fence around it. And all of a sudden everybody likes it. Got a very neat situation here, offering lots of plants to a number of different species of bees. And if everybody did that, our native bee populations would start to rebound. Or you can have a bigger plot here. Imagine the amount of life that is here compared to the amount of life that is over here. These are both Drew Latham designs. Can municipalities help us live with nature? Of course they can. And there's growing examples of where people or municipalities are doing this, like in Minnesota, that has a statewide cost-sharing program. It's actually paying homeowners to replace all or part of their lawn with appropriate prairie plantings. Great program. Florida is encouraging, there are parts of Florida that are encouraging people to have burrowing owls, a listed species, in their front yard. This is the way the Endangered Species Act should have been written. So that you're written with carrots, not with sticks. You actually get paid if you have an endangered species on your property. Then everybody would want one. Missouri had a bounty program on calorie pear, Bradford pear, highly invasive ornamental. If you brought in a calorie pear body, you got a free tree replacement. San Antonio, what is that? Public utility. It's giving $100 coupons for people to put in water-conscious native plants to help the local watershed. And of course, there's lots of programs in the far west to reduce the amount of lawn with replacing it up to $2 per square foot by removing lawn and putting in appropriate xeric plantings. I think we've made 3 missteps in the early years of conservation. And the first one is that we've assumed that nature is important but not essential, which means it's always bumped down the list of priorities. I went to the Cincinnati Zoo not long ago. They have this wall-size poster there. Many of you probably have seen it. And it reflects what I think our entire culture thinks of the importance of saving nature. We want to save it so that future generations can enjoy it. But that suggests to me that nature is just there for our entertainment. It is far more than that. We've got to save nature so that we have future generations. Second misstep is that we've assumed that humans and nature cannot coexist. And we talked about this. If we restrict conservation efforts just to areas that have no humans, they're going to fail because there are not enough places like that. Those areas will be too small and too isolated from each other to sustain the nature we're trying to sustain. David Quammen has this analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. It's 71 rug fragments, none of which are functioning like a Persian rug. And this, of course, is what we've done to our ecosystems and built no man's land in between each one of these fragments. The UN designates biosphere reserves as places of ecological significance. And I hate that terminology because it suggests there are places on the planet with no ecological significance. Every place has ecological significance, even our yards. So what we need to do is put the plants back. In between, we're in these no-man lands. We need to put those powerhouse plants back, build biological corridors, but build them so well that the species can actually live here now, not just move back and forth. We need to glue our rug back together again with appropriate plantings. Our third misstep was to leave Earth stewardship to a few specialists, ecologists, conservation biologists. We didn't see it as an inherent responsibility of every human being, and I have no idea why, because every person on the planet depends entirely on the quality of Earth's ecosystems. So why wouldn't everybody have the responsibility for good Earth stewardship? Stan Rushworth, the Cherokee elder, once said that Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. They're not born with these mindsets, they're taught them. We need to start focusing on this second one. We can have rights, but we also have obligations to take care of the planet. It's our only home. It doesn't mean that you have to save biodiversity for a living, but you can save it where you live. Now, I like this approach because it empowers each one of us, which is good because today so many of us feel powerless. We feel like one person cannot make a difference, but you can. Plant that oak tree, plant a black cherry, plant something that's going, one of those powerhouse plants. You can go out the next day and see the wildlife that has come to use it. You are now an important piece of the future of conservation. And you know, even if you don't own property, you can do it as a volunteer. Go to a local park or preserve. Everybody is short of labor and funds that will love your volunteer actions. It also shrinks the problem down to something that's manageable for each one of us. Just take care of the little piece of the earth that you're associated with. Shrink the lawn, put in a pollinator garden, get rid of your invasive plants and put in those keystone plants. And if everybody with private property did that, we'd be 85% done. So as property owners, or as volunteers, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we choose to do so is going to determine nature's fate, and ultimately our own fate. I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks for listening.